Welcome to this lesson on volume and surface area. Okay, now before we actually go on to really find out what is volume and surface area, okay, let's really think about what volume actually are we trying to find. Okay, we're going to find the volume of prisms, and we will go to cylinders as well. Okay, now what are actually prisms? Okay, so that's the main question here. What are prisms? Okay, what are actually prisms? Okay, prisms by definition in textbook is a 3D object. Not 3D, but 3D. Okay, it's a 3D object. Okay, and it is a 3D object with two identical shapes as its bases. Okay, and one criteria of it must be facing each other. Okay, so actually instead of saying as its bases, two identical shapes facing each other. Okay, with that being said, I'm just going to quickly draw a prism here that actually all of you actually should know what this is. Okay, this is actually a cuboid, right? This is actually a cuboid. Okay, so let's just quickly draw it here. Okay, this cuboid, when it's drawn in 2D, so it's a 3D object drawn in 2D, it will look something like that. But little did you know, okay, I'm going to draw the back like using dotted lines. Okay, so you can actually roughly see the entire shape, 3D shape of this cuboid. Can you see that if I treat this here as my base, the opposite side is parallel to this as well. Okay, does it satisfy the condition of being a prism? Yes, it does. Now, with that being said, okay, we're going to talk something that every prism has. Imagine if I have a cake. Okay, not cake, not any cake, but like a log cake when you eat in Christmas, during Christmas. Okay, and I cut this log cake into equal pieces. I don't cut like that, right? You made a log cake like that. Okay, I mean it's like that. Okay, I don't really going to cut like that. Right? I'm going to cut like that. Now, when I cut it, right, into half, let's say, will the side here be the same as the base? Okay, it still will, right? Okay, and what we call this actually, if I cut this cuboid into half, okay, in this direction, okay, this side will be still parallel to the bases, correct? This blue color side. And this blue color side, we're going to call it the cross section. Okay, the cross section is a very special thing. It must be parallel to the bases of the prism. Okay, quite simple. Okay, so now before we carry on, okay, from secondary school, from primary school, you actually know how to find the volume of object or cuboid. Okay, and you know that a volume is equals to base area times height. Okay, but this height, okay, let's talk about this height. This height is not any height. Okay, this height is the perpendicular height. It's a perpendicular height, right? So it must be perpendicular to the base. Alright, it must be perpendicular to the base. Hence, this is the definition we know. Now, we also said that the base and the cross section must be identical, right? Okay, I also can say the volume is just the cross section area, okay, multiplied by the height. Hence, this is how you find volume. With that being said, okay, let's look at a different kind of prism. Okay. I'm going to draw a different kind of prism here. Okay, it should look something like that. Okay, this is a triangle with a right angle. And like that. Okay. The back of it is actually looks very similar. Like this. Okay. Okay, is this a prism? Yes, it is. Can you see that? If I treat this triangle as the base are parallel to each other, they're identical to each other. And this height here is perpendicular to the base, right? So let's say I will give this 3 cm, I will give this 4 cm, and I give this 5 cm. No, let's not give it 5 cm. Let's just give it 10 cm actually. Okay, so to actually find the volume of this, we call this a triangular prism. Okay, so I'll just write it quickly here. Volume of triangular prism. Okay, this is equals to the area of the triangle, which is the base. Okay, can you see that the cross section here is also a triangle? Okay, I'm going to quickly draw out the cross section. Okay, cross section is also a triangle, it's the same. So the area of the triangle is half times 4 times 3 multiplied by the height of 10. Okay, what I have here is 60 cm cubed. Okay, volume is in cm cubed because you're multiplying area times a height. So area is already cm squared. You multiply a height of cm, it becomes cm cubed. Okay, we'll move on quickly to another kind of prism. I won't really consider it as a prism, but you know this from primary school, what this shape is. Okay, I'm not drawing it very accurately, but you all know that these are cylinders. Now, cylinders also follow the same set of rules as prism. Okay, assuming that the base areas are identical. Okay, let's give these a radius of 3 cm, and I give this a height of 4 cm. Now, to find the volume of a cylinder, okay, is this the base? Is this the bases that are parallel to each other? It fulfills this, right? And then it has a perpendicular height here, so this is perpendicular to this, right? Hence, the volume of cylinders is equals to the area is pi r squared, which is pi times 3 squared times 4. Okay, base area here is just pi r squared. Okay, so pi r squared, right? The area here. Okay, so in this case, if you use a calculator, you'll get an answer of 113 cm cubed as well. If you round off to 3 SF. So that will be all for volume.